Hi, good morning, Dr. Rahman, Dr. Wong, Dr. Lim, and also Dr. Mimi. So today I'm gonna talk about my research topic, synthesization and characterization of alpha and beta gallium oxide-based thin film using the mixed CVD technique. So my name is Lo Kian Ping, and my metric number is P103776, and currently I'm the first semester. I'm taking course of Master in Science in microengineering and nanoelectronics, and all these names are my supervisor. So as it comes to my introduction of my research proposal, so it has known that Lico de Bois Baldron was the first scientist to discover the elements of gallium. And gallium oxide is also belongs to the conducting transparent oxide semiconductor material, which is then for further research or further development, it has found out that it has five commonly identified polymorph, which is alpha corrodum, beta monoclinic, gamma defective spinel, and delta orthorhombic. And also lastly is the epsilon phase of gallium oxide. And gallium oxide is also known as the outstanding material properties, which can enable the power device in order to break down high voltage and also have a better performance efficiency compared to the SiC and gallium nitride. And this has drawn the most of the attention for the researcher from all over the world. So next is my problem statement. So the problem statement which have found that different condition will yield different kinds of polymorphs for the gallium oxide, such as alpha, beta, gamma, and delta epsilon. So one of the method that I'm using now is the mixed CVD technique. And this technique is still have some flaw, which is one of the most obvious problem statement, whereby the mixed CVD might not be consistent in obtaining the most stable state of the gallium oxide thin film that is originally deposited on the sapphire substrate. And in order to solve this problem, we are trying to adjusting the parameters such as the flow rate of the gas, temperature of the heating furnace in order to overcome the fundamental limitation of the mixed CVD technique. So this could result in a better characterization in terms of the electrical and optical properties for the gallium oxide thin film structures. So there has three research objectives for me. So the first one is to enhance the formation of the gallium oxide thin film by varying the parameters. And the second one is to investigate the structural properties of the gallium oxide thin film crystal, whereby it's incorporating into the sapphire substrates. And for the third is which is to optimize and study the condition of the gallium oxide thin film structure. And for the hypothesis, this has been my opinion for it is because that when using different kind of the fabricating technique, it will eventually affect the characterization of the gallium oxide thin film. So it was expecting the linear optical functions of the thin film of the alpha and beta gallium oxide in the UV with spectral range. So this XRD result will eventually reveal the nanocrystalline morphology with a crystalline size of less than 10 nanometer for the gallium oxide thin film structure. So this accuracy data will eventually deducing from the layer model based analysis, which is from the material studio that I am using it right now in order to simulate a better and also optimize gallium oxide thin film structure. So this simulation structure is very deeply relying on the model quality from the synthesis action of the gallium oxide thin film. And besides, there has one more last condition, which is we need to take note of the quality of the sapphire substrate. This is because this might eventually affect the final result of the characterization. So now comes to the literature review. So as it knows that for gallium oxide have five polymorph, which is alpha, beta, gamma, delta, and epsilon. So all of these are considered one of the semiconductor family. This is because they have a transparency conductor oxide, and also it is very conductive. And each of the polymorph will show their phases of gallium oxide that is prepared under certain specific conditions, and it might eventually create different kind of polymorphs with different conditions. So for example, for my experiment, alpha and beta gallium oxide is actually the things that I'm trying to focus. And for beta gallium oxide, I am preparing by heating the nitride, acetate, and oxalate from the other and also other organic derivatives, which is above 1000 degrees Celsius. So by keep on heating the furnace with the temperature of 1000 degrees Celsius, it will eventually form the beta gallium oxide thin film in the furnace. And another polymorph that I'm focusing is the alpha gallium oxide. With this is preparing by heating the beta gallium oxide. But it has a certain condition, which is the pressure. It needs to be heated at 1100 degrees Celsius at 65 kilobars. And also for the gallium oxide thin film, it has a wide bandgap range. The range is about 5.3 to 8.8 eV. This same goes as the alpha and beta as well. So as for the mid CVD that I would like to mentioning, which is this technique is really cost effective. It's because it's very simple to set up, and also it has a vast potential of the multi wafer, and also is large scale for the growth apparatus for the mid CVD. And now comes with the research methodology. I have three stages for my research methodology. The first stage is my synthesizing of gallium oxide by using the mid-CVD method. So this need to be deciding on the parameters such as temperature and flow rate of the gases during the experiment. And another condition that I need to consider, which is the characterizing different implant parameters of the sapphire substrate. And the next one is designing the new structure of the gallium oxide through the simulation process by using the Material Studio software 8.0. So this purpose is to design an optimization of gallium oxide thin film that is done by using this software. And this simulation structure is considered as the optimized condition for the gallium oxide thin film, and the sapphire substrate that will be picked on as a suggestion or reference, that is to the main goal is to focus on the better performance efficiency during the final stage when the gallium oxide has already been produced. So it must be the best quality that I'm trying to synthesizing it. And also lastly, for my research methodology stage is the optimization and characterization of gallium oxide thin film. So this has involved the UVVs and also XRD in order to determine the optical properties of the gallium oxide thin film. And on the other hand, for the structural characterization, it will be utilizing the FENSEM, TEM, AFM, XRD, optical microscope. This is to observe the gallium oxide thin film structure without any significant lattice mismatch between the gallium oxide and sapphire substrates. And all the structural analysis will be varies with the different parameters, like what I mentioning previously, which is the temperature of the heating furnace and also the flow rate of the gas. And lastly, comes to the conclusion. In my conclusion, flow rate of gases and temperature of heating furnace are the most important parameters to determine the alpha and beta gallium oxide. And for the second one, which is the FENSEM, TEN, AFM, and optical microscope, which is help to determine the structural properties by going through the process of the structural analysis with all these instruments that I'm using. And lastly, for the optical characterization process, I will be using the XRD and UV-Vis in order to determine the electrical and optical characteristics of the gallium oxide thin film. So for my potential research of my intellectual property for the commercialization, so I will be involving with develop the simple and affordable price and also high efficiency of the gallium oxide thin film. And I'm hoping to collaborate with the solar cell researcher so that I could produce the solar cell semiconductor chip, which is quite novelty and still nobody doing it. So this might be also my PhD for my next focus goal. And this solar cell semiconductor chip, which is very good, this is because it can help to conserve and preserve the environment, and also it saves a lot of electrical energy that is burning from the unwanted coal and also fossil fuel. And this semiconductor chip will eventually go green, and which is eventually bring a lot of major contribution to the society and the global world, and is also avoiding any of the pollution from the environment. And so this is my Gantt chart. And for the project activities that I will be involving is the synthesis of the gallium oxide thin film, and also the preparation for my experimental setup, which is I'm currently still waiting with the 2.4 megahertz of the ultrasonic transducer and also a better quartz glass container in order to observe the internal condition of my Miss CVD. This is because with the transparent container, it can observe whether the gallium acetate solution will eventually form the mist and generate it and transfer it to the heating furnace. And for my third stage, which is the characterization, I will be using the UV-Vis, XRD, PL measurement, AFM, FENSEM, TM, and also my optical microscope to observe the optical and structural properties of the gallium oxide thin film. So this could be extended until next year, 2021, of next year June. This is because it might be taking quite a long time to synthesize a perfect gallium oxide thin film also. So I'm putting it as 1 year for me to complete all my characterization characterization stages. And also for the next stages is the fabrication. I will also be fabricate the solar blind UV photo detector, and with the perfect gallium oxide thin film, you will need to etch with other elements as well, such as titanium, aurum, in order to form a metal semiconductor metal structure of the semiconductor thin film. This is because like MSM structure is a very perfect structure for better working efficiency for the semiconductor. Therefore, it can also help to detect the light easily for the solar blind UV photo detector. So it'll be up to next year October 2021. And finally, it's come when it comes to the report writing and thesis submission. I'm planning it to finish everything next year December, so that I can graduate on time. And this is all I have that I want to present. And this is the end. And thank you very much for listening for my presentation.